they taught me to tell you what you're going to learn today first, and so that's the first thing I'm going to say. And you're going to learn two things. And if there's two takeaways from today, besides how to be an awesome SRE like Nori, those two things are, first, Istio and a bunch of the other things we're developing at Google give you the tools that you need to start SREing like Google SREs. And second, it's working now.
And second, Dan's going to tell you all about what Istio actually is.
You've probably heard this word a lot at this conference, and probably, how many people had never heard the word Istio before they came to Google Cloud Next? A chunk of you. We're going to make sure that you know what that is. But first of all, who are we?
So as I mentioned, my name is Nori. I've been at Google for 13 years and SRE for 10 of that. During my time in SRE, I've worked basically exclusively on infrastructure. My first SRE team at Google worked on the infrastructure powering basically all of the services that Google provides, all of the DNS, all the load balancing, DOS protection, stuff like that. And in the last 2 years, I've been working on a team that is responsible for the infrastructure powering Google Cloud. My team is responsible for the production health of App Engine Flexible Environment and GKE. And what I always like to say about the teams I work on is the y-axis of our graphs is pretty nice.
My name is Dan Ciruli, and I am a product manager. I've been at Google for about 5 years, and I've spent that entire time working on Google's own APIs and services infrastructure, the stuff that serves the Maps APIs, the Drive APIs, the YouTube APIs, and of course, all the cloud APIs. And for the last couple of years, we've been focused on productizing that technology, and that's in the form of some commercial products, like Google Cloud Endpoints, and most recently, open source efforts like gRPC and Istio.
So SRE, as I'm sure you're aware because you're here, stands for Site Reliability Engineering. And we call it Site Reliability Engineering because it's a term that Google made up because many years ago, Google was just a website. And these days, it's a little more than that, but the term is stuck around. In the beginning, when it was just a group of software engineers working on web search, they set up alerting, they set up monitoring, as I'm going to tell you all about in a few brief slides. And they sent their alerting targets to page everyone all at the same time when there was a problem. And they found that a few people were always the same ones who were responding to alerts. And those people eventually sort of gravitated into the role that became SRE. And what I like about this role is it's still operationally driven. We still get paged, and we have to fix the problems. But it is, at its basis, an engineering role. So instead of taking your classic ops role from a generation ago, where you get paged at 2 in the morning, you don't know what's happening, you have to fix the proximate cause, but that's about all you could do. In SRE, we do get paged, ideally not at 2 in the morning. We have pretty good 2-site SRE team distribution. But you fix the proximate cause, you always mitigate first. But then you do a root cause analysis or a blameless postmortem. You understand what really happened and what drove you to this situation. And then it's not only an option, but it's in fact your job to fix the problem so that the same thing never happens again. And that's why I like it. It's really got the balance of both of those. SRE has learned a lot during the last decade, in fact more than a decade. Initially that was how to run systems at scale, power a Google web search, and then all of the apps that run the similar infrastructure inside of Google. But more recently, we've been learning how to leverage that knowledge and bring it not only to Google Cloud, but also into the open source community. This is a book that our department sort of collectively wrote. It describes many SRE best practices. And I'm on stage with Dan right now because Istio actually enables you to implement many of these best practices straight out of the box.
By the way, I don't know if any of you have been in any sessions today that use the Dory. The Dory is a Q&A tool that we use internally at Google, and as an experiment, we're letting you guys use it here today. So if you do come up with any questions during the course of the talk, if you open up the Next 18 app and go to this session, you'll see a little link that says Dory Q&A. It lets you enter question and also lets you vote on questions. So it ensures that if there's something everybody's dying to ask but no one gets up to the microphone, you can upvote questions. So whether you're submitting questions or just voting, please feel free to use that tool.
And I'm also told to mention on that one that we are able to go back after the talk and respond to these questions that we may not have gotten a chance to answer during the session in the tool. You'll have to go back into the tool to view that. We can't send email notifications, but you'll be able to see some more answers there later.
So I do want to start by talking about Istio. What is Istio, and why is everybody talking about it so much? We're getting a lot of N+1 redundancy here. That's apparently not.
Do you want me to just?
Yeah, please do. Oh, hey. Right arrow? Figure out how to get to the next slide. Maybe try the other thing. So Istio is a service mesh. And you're probably hearing this term if you look at the Google Trends on service mesh. It is an area of big interest and increasing interest. And I want to describe a service mesh in a few number of words. The important things about a service mesh is that it automates away a lot of the things that we typically build on top of our network stacks. Automates away things like seeing what's going on in terms of traffic to your services, providing authentication and authorization on top of those. So it does that, but very importantly, to be considered a service mesh, you have to do that in a transparent way. A service mesh isn't something you code to, necessarily. In fact, most developers should never even know it's there. It has to be something that can layer in on top of whatever you're already doing, whatever language you're already using, whatever platform you like to deploy on. The idea of a service mesh is to automate a lot of the functionality out of the network, up-level what the network gives you in a completely transparent and language-independent way. And Istio is not just a service mesh, but it's an open services platform. There are a few different service meshes that have come out in the last couple of years, and where Istio differentiates is by defining a set of APIs that make it easy to integrate back-end systems as well. So arbitrary, you log wherever you want to, you monitor wherever you want to, you use whatever arbitrary policy engines you want to. And again, all your services are taking advantage of that without coding themselves, without integrating into the service mesh explicitly. And this, we talk about it a lot in the context of Kubernetes, but Istio is not dependent on, it's not dependent that you only deploy workloads in Kubernetes. We do have people who are deploying workloads across VMs as well. So what does it do? What is the functionality that it offers you once you layer in this transparent service mesh? The first thing is observability. It's kind of unbelievable how many people out there are deploying apps into Kubernetes and have no idea what's going on in those applications. It gives you good visibility into what's happening in a distributed application. The second thing, it says operational agility. And by operational agility, what I mean is being able to control where a request goes and be able to have a safe and sane way to roll out new versions of services as you're doing that, and be able to control, hey, maybe we need to send traffic to a different region right now because this one is very busy or overloaded. And then the third major area of functionality is security, is allowing you to secure traffic between services and ensuring that now that your application has gone from being a monolith to being composed of, say, 100 separate services, how do you ensure that each of those is secure? So three big things for Istio: observability, agility, and security. How does it do that? I won't go through all the components, but I will tell you that the key here is through the use of a sidecar proxy. Sidecar proxy is simply a proxy that gets deployed alongside your application. If you're doing this in a VM, you've got to make sure that proxy gets installed in the VM. But if you're using Kubernetes, Kubernetes has great features that allow that to happen transparently. So whenever you deploy a pod, you put whatever you want in your containers, Kubernetes can automatically deploy the sidecar alongside your pod. And all traffic into and out of your service goes through that proxy. And that means it can make smart decisions about how to route that call, and we'll get into some details later about what that means. But also, as a call comes in, can make decisions about whether or not that call should be allowed in. It does all that, again, transparently. Your services can be communicating via whatever protocol they want. HTTP for most of you, gRPC for some of you. Could be just a TCP connection. It doesn't matter to us. All the traffic goes in and out, and by interposing that proxy in there, we get to add in some functionality. This project is something we started about 18 months ago, and we have been working with some partners the whole time. IBM and Lyft both started from the very beginning with us. We use Lyft's Envoy proxy, super performant, small footprint proxy that we really like. And is really getting great adoption across the industry. But we're also working with a bunch of other pretty heavy hitters in the industry. Red Hat is working on this. VMware has done a bunch of work on it. We're working with Cisco. And so we're really trying to get a consortium of people from around the industry to say, hey, this is a good way to do this. This is a good way to solve this problem. And we're getting as many companies as we can behind it.
So the first point Dan mentioned a couple slides ago was observability. So I'm going to give you a little bit of background about observability best practices and then how we've implemented those at Google. So the first thing is observability begins with monitoring. Now, I admit that calling monitoring an SRE best practice is a bit of an exaggeration. It's very fundamental. A brief story about this. So when Mikey Dickerson, who's a former Google SRE, went out to DC as part of the tech surge to help fix healthcare.gov a few years ago, he found that they had no monitoring. Well, correction, they actually did have a very basic form of monitoring. It was a TV on the wall, and it was playing CNN. And whenever CNN reported, this is no joke, whenever CNN reported that healthcare.gov was down, they knew they had a problem. They should probably go fix it. So
anyone else use CNN as a service? They're the only ones.
I'll tell you how to fix that. Mikey perhaps got a little exasperated and drew them a hierarchy of needs. He called it a reliability hierarchy, and this has become known as the Dickerson hierarchy of reliability since then, modeled, of course, after Maslow's hierarchy of needs of physiological safety first, and then on up through friendship and things like that. In the Dickerson hierarchy of reliability, you have monitoring right at the bottom, because having CNN on the wall is not an acceptable form of monitoring. And so in this pyramid that I'm going to show right now, I've sort of extrapolated monitoring out into its own sort of pyramid with its sub-building blocks. So what should you monitor? At Google, over the course of developing many best practices over the years, we've decided that we have at least 4 golden signals. And these are 4 things that if you monitor, will give you a really good basic insight into how your system is doing. And they are, in this order, traffic. How many requests are coming into your system? This is commonly known as RPS, requests per second. At Google, we still call them QPS for most of our systems because every request is a web search query, right? That sort of stuck around. But this is your building block here, is how much traffic are you serving? Beyond this is errors. Of that traffic that you're serving, are you serving it successfully? Are you serving any of it successfully? Are you serving all of it successfully? You need to be monitoring not only the requests that come into your system, but also the percentage of them that fail. And I do mean percentage. You have to start with traffic, so you have a denominator here. But if you know that you have 1,000 errors per second that you're serving, that's probably a bad thing. But if 1,000 requests per second, or QPS, is actually 0.001% of your overall traffic, that might be like an acceptable-ish amount of errors. So this is a rate here. The next one is latency. And we'll find that as we go up this pyramid, we're sort of moving out of the realm of we need oxygen and we need water, and more into things like we need friendship. And latency is a really good sort of friendship analogy in this monitoring pyramid here. Latency is not quite as fundamental as traffic and errors, but you still need to be monitoring latency to understand the overall performance of your system. Users expect apps to be super fast these days. And in this highly networked world, most of that budget for latency is going to come out of your code. And so you do want to be measuring latency. An interesting note on how to do this here, don't just do this as a straight average. Latency, if you took the average of all the latency of all of the requests coming into and out of your system, you would end up eliding some important points. You wouldn't get a sense of what the common experience of your app is because you might have some requests way out at your long tail, which for various reasons might be taking a very long time to complete. And these could be for legitimate reasons or reasons that you want to look into a little more deeply. But either way, it's really good to break that out. And so when we talk about monitoring latency at Google, we talk about it in terms of generally 3 numbers. We talk about the 50th percentile, or the median latency. We often refer to that as P50, and then the 90th percentile, P90, and then P99 as well. And taking those 3 lines as separate, you usually see them, P50 is pretty steady state for your system. P90 is probably generally a little higher, but should still be within the realm of normal. And P99 is a really interesting signal to split out here. So I think that's just an important concept to mention, that latency as an average is not going to get you very far. And finally, saturation. This is a metric that is even fuzzier, and this one is up to you to define a little more than the other 3. Saturation is the idea of at what point is your service just going to fall over. If you had no load shedding, no auto scaling enabled, nothing like that, you need to know about the capacity of your service. So this could be as simple as CPU utilization. It's a very common saturation metric out of the box. But it also might be that based on your knowledge of your own system, it's actually a much more complicated metric that you calculate and that you can export a variable based on this one. But what you want to do with saturation is feed that into things I mentioned, such as auto-scaling. It can be a signal to tell the system that it's time to auto-scale up and add more tasks. It can be a signal to load shedding, to say that the system is full, we can't auto-scale anymore, and we want to start dropping queries. It could just be a white box signal to page a human and say, please come add more jobs. We're about to fall over. The system is almost at capacity. But no matter how you treat it, these saturation is the sort of 4th of these golden signals that, taken together, form a pretty good idea of the health of your overall system. So in the old days at Google, whenever a new service wanted to launch, they would have to basically write their own monitoring from scratch. And it wasn't quite as dire as that. I mean, there was a standard library. Each service would include this standard library, and they'd export a standard set of variables, requests per second, errors, et cetera. But then the manual part was that each new service owner had to manually aggregate these and define the monitoring configuration to aggregate these all up, and then define what were the dashboards going to look like. It was a very tedious process. Trust me, I did it once. I've got the badge to prove it, but I don't want to do it again. And so what's cool these days is that when new services launch, or really when you turn up any job in our production environment, you get this for free these days. Now we use a sidecar proxy. And this sidecar proxy is automatically collecting the metrics that I mentioned. It's collecting the golden signals and a fair number of other ones besides. And it automatically puts these into a dashboard for you. So these days, when we have this automatic aggregation, this is a screenshot of the dashboard that you'll see. We just picked an arbitrary small service here. But you can see that these are 3 basic graphs that just list out the golden signals. No work was done on the part of the service owner to get these graphs. This is observability for free. This has been an incredibly powerful concept at Google. Not only does it remove the need for each individual service owner to redefine their monitoring from scratch, but it also means that when you want to look into the performance of somebody else's system within our organization, you can do that. And so in many cases, again, in the old days, we would maintain these lists of links to the various monitoring dashboards and these other services, and you hope that then you remember to find where your page of aggregated links is and that nobody else moved their dashboards or they're not down, and it was a bit of a nightmare. And these days, if you have a service that has a dependency on some other service, you suspect the dependency may be at fault in some issue you're currently debugging, you don't have to find your bookmarked link. You can just go to our central automatic monitoring dashboard, type in their service name, and view their dashboards. It's so cool. Of course, these other services can go in and tweak these metrics themselves. They can make custom dashboards. They can make it prettier. But what you're seeing here is that out of the box, at Google, you just get dashboards for free. And these are a couple zoom-in dashboards here. This is the top one you see. This is requests and errors. There's 3 lines on here, and so we actually almost always will graph the request per second against errors per second there, and 2 types of errors in this one. We also have the internal error ratio, which is the second piece of that monitoring pyramid. And latency. Again, you'll notice on the latency graph, there's those 3 lines. And the red one is P50 latency. Pretty normal realm for that one. The next one up is P90 latency, and that's still within a normal realm. You can see in this particular graph, it's about double of what the P50 latency is. That may or may not be expected based on the performance of your system. But then P99 latency, I think this perfectly illustrates why it's really important to split these out into their own bands so you can reason about them separately. The other part of observability as a complement to the metrics and the dashboards is logging. When you're debugging an issue, dashboards are a great start, and often they'll tell you what you need to know. Sometimes you'll see a steep drop-off on the number of running tasks or a steep uptick in the number of queries per second coming to your system. Those are great places to start. But occasionally you'll get into a really gnarly issue where you need to dig into exactly what happened at a certain period of time. At Google, our systems generate huge volume of logs. They're doing huge volume of requests at all times. We basically log everything. We have reasonable retention periods, but for a finite period of time, when you're trying to understand what happened in your system, you can go back and dig through these logs to try to figure out in precise detail what happened. But the only reason this works at all is that we have tools to help us slice and dice this data. Petabytes of logs are useless if all you have is grep. And there was a groan. Yep, that's how I feel about that one. Dremel is our internal SQL-like interface over these huge volumes of logs. It lets us drill down into what's happening at the precise moment we need it, and it's a much more powerful tool than simply trying to open these up in your editor and muck around to try to distill down. I have been at Google long enough that it turns out that this Dremel is such a power tool for me that it took me many years, more than I'd like to admit, of being an SRE before somebody actually pointed out to me that a Dremel is a real physical thing.
Great. So thank you, Nori, for that, and explaining what are these things that we feel you need to have, the tools in your arsenal that you need if you want to be an SRE. And now I want to talk a little bit about how Istio gives you some of those tools. Sure, I can drive, I suppose. Didn't like me before. Again, emphasizing what I said about a service mesh, you can get observability today. All of you are doing some monitoring. No one is really using CNN, right? But what tends to happen is different teams solve this in different ways. And if you're running operations, depending on which team developed a service, you might have a different set of metrics. Some things might be gathered from logs. Other people are somehow sending telemetry somewhere. Other things, they would like to use the same metrics that that team has, but they're developing in a different language, and the client library just doesn't work as well in Node as it does in Java, say. So with Istio, we want to give a standard set of metrics without doing any integration, without language-specific client libraries. And out of the box, we give you most of the golden signals: traffic, errors, and latency, the things that Nori said. You can't really run a service well without these metrics. We give you that out of the box. So every service that you're deploying into your service mesh, you get that out of the box. Now, as she said, saturation is different for every service. In some cases, it might be CPU. In some cases, it might be RAM. And some other ones, it might be a number of operations going to disk. You'll have to figure that out for your service. But for most of these, out of the box, we'll gather them, and we'll send them to the location of your choosing. And to do that, we use a component in Istio called Mixer. Mixer is a runtime component we deploy into your Kubernetes cluster. And it has a very pluggable architecture. All of these sidecar proxies, when they receive requests, when they return requests, they are sending all this telemetry to Mixer. Mixer then can plug into the system of your choice. Maybe you're using Prometheus. Maybe you just run an InfluxDB. Maybe you're using external vendors. People are writing these already, and certainly we have a fantastic one for our Stackdriver tool. So Mixer is the component that we won't get into policy today, but in addition to enforcing policy, it also gathers all the telemetry and sends it out. And of course, we think a great place to send this is Stackdriver. This is in alpha in Stackdriver today, and it's a fantastic view into not just what's going on with a particular service, but how these services are interoperating. This is a dependency graph, and it builds this graph depending on the actual traffic observed in your system. This is a really big deal. When someone joins your team tomorrow, I guarantee you someone is going to go to a whiteboard and draw a picture of what all your services are. And I can also guarantee it's probably wrong. I know this from when we got this at Google. People don't know their dependencies. They don't know who's dependent on them. This actually knows, and it can tell you. And it can tell you not just how much traffic you're getting, but how much your traffic you're getting from each client. When things are running slowly, this can help you root it out very quickly. And as you can see on the left there, you get the golden signals for every one of these. You get your traffic, you get your errors, and you get your latency. We collect all your logs too. And I sometimes talk to customers and they ask, well, what percentage of our requests should be logged? And the answer is easy. It's a triple-digit number. Right? You log all your requests. You don't have to keep them forever. But when something goes wrong, you never know which request was going to make that thing go wrong. And if you weren't logging, you're in trouble. But as Nori said, lots of logs are difficult to deal with and almost unusable unless you have good tools. Stackdriver logs has got a great logs viewer, but even better, you can pipe it into BigQuery. And in BigQuery, it's Dremel. You can write great SQL queries across those logs to do analytics. You can figure out what wrong went in a particular event and big analytics things. It's a really, really powerful tool. I didn't get into tracing, but Istio is also gathering tracing for you as well. Now talk about SLIs.
So once you're monitoring your service, you can use these signals to talk about health at the service level, and then also to help you plan how you're going to react if those signals start to dip a little bit. So there's lots of TLAs in this space. Please bear with me. An SLI. This is metrics, essentially. This is basically the golden signals are a great place to start. They are just a sense of what's happening in your system on a quantifiable basis. Also, I should note that these are often the things that you define your alerts on. Alerting isn't something I could give its own 50-minute talk about, but very briefly, if you alert on the golden signals, that's a great place to start. SLO uses the SLIs. These are targets for these metrics. They're either target values or target ranges. Pro tip here, 100% is not a good SLO. Typical availability ranges are measured in number of nines. This is, again, very service dependent. It may be 2 nines, depending 99%, depending on what your service can reasonably achieve. Or it might be 5 or 6 nines, a very highly available service. But again, 100% is just never going to happen. One of the fundamental tenets of engineering for reliability is you have to plan for failure. Things are going to break. Machines are going to break. VMs are going to break. The network is going to go down. There will be failures, and so assuming or just hoping that they will never happen is, as we say in SRE, not a strategy. So set a really high service level objective, but measure it in nines and don't use 100% here. And an SLA is a legal agreement. This is basically a threshold after which the customer, or your customers, depending on which direction you're talking about, get remunerations or other things coming back to them in breach of the contract. So when we're talking about reliability from the engineering standpoint, very often internally we're speaking of SLIs and SLOs, because those are the things that we have the most direct control over, choosing what to measure and then choosing what thresholds are actually achievable. And we leave SLAs to the more business and legal end of the company. Another way of saying SLO is by, instead of looking at the area under that target threshold, looking at the area above, and that's your error budget. I love this concept. People can think of it, and typically do, very productively as a constraint. And I think that's great, and I'll talk through why I like that in a minute. But I think it's also important to remember that the flip side of that is that it can be permissive as well. So the constraint side, this is the typical way to think about an error budget. You set your SLOs, you monitor, you define alerts, you have those alerts paging humans or maybe feeding back into automated systems to take action. And then you take some sort of action at the system level to increase reliability if you dip down below your error budget. Again, this could be its own 50-minute talk, but very briefly, a typical response to going out of error budget is to freeze. Freezes are basically the idea of you stop pushing change live to your system. Change, be it in the form of a new release candidate of your binary or binaries, or even more config. We recognize that all of these things are vectors of instability. And so you need to manage that instability. Typically, the way you do this is you just stop pushing until you're back within your error budget to recover that. And the idea here is twofold. One, it gives your customers or your users a greater period of stability because you just experience an outage or maybe a very slow trickle of outages. And you'd like to have them have overall a very good experience. But the other idea here is that typically you can redirect the engineering effort that would have been going into new features into reliability work. The flip side of this is the way in which an error budget is permissive. As a former manager of mine used to say, what good are all those 9s if you can't take them out for a spin every now and then? But I didn't say it jokingly, and so did he. But what I like about this is it actually gives you a good sense of when it is a good time to take extra risks. Is it a good time right before your big annual conference? Probably not. But if you the week after, if you are well within your error budget and your engineers have been asking to try out a crazy new feature that's very well tested but does carry a greater degree of risk, you have a budget to spend. That's why I like to think of it as a budget.
If you've ever been waiting for a new feature from some Google product and it seemed to get delayed, maybe a month later than you wanted it, it may be that team ran out of budget and they weren't permitted to launch that feature. It really does affect how we launch things. So now I want to talk a little bit about one of the very cool things that isn't specific to Istio alone, but is something that you get when you combine Istio and Stackdriver. And that's the ability to monitor your SLIs and define SLOs. So I mentioned this before, but we are shipping today in open source an adapter with Istio to send your metrics to Stackdriver. That includes your traces, it includes your logs, but of course the telemetry, the things that were powering that graph I showed you before. Well, they've got a nifty new feature, and their nifty new feature is the ability to set service level objectives. And what's awesome is because they're getting the metrics from your services, you can now set SLOs, service level objectives, on the golden signals. It seems like an obvious thing, but it's a fantastic thing. I literally know customers who alert because they have their logs, they scrape their logs, they send their logs to a third-party vendor where they can write a grep, run that grep every, say, 5 or 15 minutes, and then if they have too many errors, do an alert. Who does something like that? Some of you are not being completely truthful. I know that's happening. It's a really, really like you might as well turn on CNN. Like this is the way you should be doing this. Have something that's gathering your telemetry, set an initiative, say, hey, I want to make sure that we are available, that we're returning our requests successfully, say every week. You might do it per month, you might do it per quarter, and say I want that to be at a certain range, 91, 92%. Now you set this objective within Stackdriver, and Stackdriver will alert you if you get out of compliance. Now you might not set this where your SLA is. If you're telling your customers, 99.9, you might set this a little bit higher so that you get alerted before you're out of compliance. But then they will let you monitor this. They'll show you here's how you're doing against your goal, and you can see sometimes I'm above, sometimes I'm below. But what's important, they'll show you on your budget as well. In the aggregate, are we doing okay or are we not? Are we positive or are we negative? So it's a really fantastic tool. It's taking some very basic concepts. If you've read the SRE book, you will have read about this, and you may have thought, wow, error budgets sound cool. How would I implement that? The good news is that they just did, and that you can take advantage of this. And now back to you.
So another SRE best practice is that of canary releases. And we do that so much we call it canarying. So as I mentioned when I was talking about freezes, new releases commonly cause instability. So you need to manage that instability. Canary jobs are small jobs that are basically identical to all of the other workloads that you have running in production, but they're configured to get traffic early. And they are also, importantly, take a very small fraction of your traffic. And so the same concept applies as the canary in the mine shaft. You send the canary down the mine shaft first so that if toxic fumes have built up down there, the canary keels over instead of all of the mining team all at once. Same concept applies here. If you send a binary down into the mine shaft. This analogy is breaking down. And it falls over. You know then to not immediately continue your rollout to all of production all at once, creating a huge outage. A couple points about how to do canarying effectively. One is you need to monitor the canary. Because this is, remember, running a very small percentage of your traffic, it might be 1% of your traffic, it might be even less than that, depending on your service, you need to monitor it independently. If you just fold it into the monitoring for your overall service, the errors coming for it, even if the canary is loudly cheeping in its death throes, are going to get folded in to the rest of your overall aggregate alerting, and very likely you won't hear about it. So you need specific alerting on your canary tasks or your canary jobs, and they need to be causing somebody to take an action. Either that's the automated rollout server automatically rolls back, or a human hits the pause button or something. But either way, you need to monitor these independently so that you can catch things early, which is the whole point. And the other thing is you need to pace yourself. Your service may go through peaks and valleys. In web search back in the day, probably still, we had a nice diurnal curve. And your service may have different traffic characteristics. Also, depending on the deployment of your service, the various locations may receive a different traffic mix. And so you ideally want to have canary jobs in each region or in each place or each configuration that has a unique sort of perspective on your service, just to get the best signal you can. And so you want to go slowly here, whatever that means for your service. In the case of something like web search, you might choose to do a one-day canary period, just to get the full diurnal cycle and make sure that your canary really sees all kinds of traffic. In something where you have a much more aggressive CI/CD on a every half-hour basis, the canary may only be 30 seconds or a minute or something. But this is something that you're going to want to define to be meaningfully slow for your service.
Guess what? Istio helps with that too. So I want to start by talking about the problem with Kubernetes. And by the way, Nori did say, Dan, are you sure you want to title a slide the problem with Kubernetes? And I laughed and I said, yes. Someone else said, are you sure you don't want to just call it a problem with Kubernetes? Because there might be more than one. But one problem with Kubernetes is that Kubernetes, it load balances. If you've got a workload that's running at enough scale that you need 2 pods, it'll load balance between those 2 pods. So if version 1, you're doing enough QPS that it takes 2 to satisfy that, it'll run 2. Well, say you've got a new version of that binary that you deploy. What is Kubernetes going to do? Well, it'll bring up a new version of that pod, and it will get an equal share of the traffic. This is not a best practice in Kubernetes. If you need a 1% rollout, you shouldn't need to run 99 pods of your other thing in order to achieve that 1% rollout. But that's literally what you would have to do, and I've heard vendors talk about things just like that. That's not the right way to do things. As she said, you want to start with something small, 1%. For us, sometimes it's 0.1%. And then you want to go to, say, 10. And then you want to go to 20 or 50, right? But you want to control the pace of the rollout, not with the number of pods that are running, but with something a little bit more explicit. So we have a component called Pilot, and Pilot is a component that pushes route rules to the sidecar proxies. And what this gives us is the ability to do load balancing, but importantly, it enables us, by the way, this is also running an ingress, so for traffic coming from off the internet, it's also going through an Envoy proxy. And Pilot can tell your services, whether they're the ingress or whether it's service-to-service traffic, hey, there's a new version of this one, but you should only send 1% of the traffic to that. So it's easy. It's YAML, and here you see I've got some YAML that shows we've got V1. I want that to get a weight of 90, and I've got a V2, and I want that to get a weight of 10. So in Kubernetes, it's still running 3 pods, but they're not getting equal shares. Instead, that version 2 is getting the 10% you want. And of course, we are gathering the metrics from it. We're gathering the telemetry so we can actually do the thing that you really want, which is you can look at your telemetry for just that canary and you can say, is it compliant? Are the error ratios where we expect them to be? Are the latencies where they expect to be? And if so, then we'll go to that next phase. So getting started with Istio, we'd love for you to get started with Istio. As I said, we've been going at it about 18 months. We are very, very close to declaring it 1.0. That'll happen any day now. We've done a lot of work. This is not a half-baked project. We have over 200 developers have contributed to the project. We're very happy about that, from a bunch of different companies, as I said. We've got it in production. eBay was on stage, I think, talking about it and sitting in the front row here. We have a few different customers, Auto Trader in the UK. We've got people who are doing hundreds of thousands of requests a second. We have people who are doing more than 1,000 services. These are all production use cases I'm talking about. We've got adapters for many monitoring systems, including, of course, Stackdriver. And what Urs announced on stage yesterday was managed Istio as part of our coming cloud services platform. We are just about to go into alpha on managed Istio, and that's Istio automatically installed, upgraded, and supported in GKE. So you can get started soon.